Now this is going to be a lengthy question. This is question number 8. So an experiment is conducted to measure the electrical resistivity of nichrome in the form of wires with different lengths and cross-section areas. For one set of measurement, a student uses 30 gauge wire which has a cross-section area of 7.3 into 10 power minus 8. Area is 7.3 into 10 power minus 8. And then the student measures the potential difference across the wire and the current in the wire with a voltmeter and an ammeter respectively. For each set of measurements given in the table taken on wires of 3 different lengths, calculate the resistance of the wires and the corresponding values of resistivity. What is the average value of resistivity? And C, in the C option, or in the C part, it is asking explain how this value compares with the value given in the table of resistivities and temperature coefficient of resistivity of various materials. So in the C part, it is just asking for um, comparing the values obtained in practical with the values or the standard values given for the material. So we have the table. So the best practice for this question is just make a table. I'll make it with red. This, then I'll write this is length here. This is potential difference, volts. This is current in amperes. This will be resistance in ohms, and this will be resistivity in ohm meter. Now length given here is 5.54, 1.28 and 1.543, 1028, and voltage is 5.22, 5.82 and 5.94. Current. Now the formula for resistance or relation between resistance is basically V is equal to I times R, or voltage is equal to current times resistance. So in this way we can calculate R, which is V by I. So this R is going to be calculated with this formula, and for calculate resistance and resistivity for 1, 2 and 3. So I'll calculate for first one, and as soon as we calculate, we'll just write the value in the table. So for first one, let's say this is A, B and C. So for A1 we have R equals to V over I, which is V given here is 5.22 and I is 0.72. So this will be 5.22 over 0.72, 7.25 ohms. Here is my pen, 7 ohms. And then resistivity will be A into R in over L. So A was 7.3 into 10 power minus 8 meters square. 7.3 into 10 power minus 8. Resistance was 7.25 and the length is I'll just use the values from this table instead of scrolling again and again. So length is 0.54 times 7.3 times 10 power negative 8 over 0.54. This will be 9.8 into 10 power minus 7 ohm meter. I'll just write the value here in the table. So this was 7.25 and 9.8, red color, 5 and 0.8 to 10 power minus 7. Now let's go for B1, the second observation. In second we have resistance. Now I'll just directly write the equation instead of writing formulas again and again. This is B is 5.82 over 1.028. So this is going to be using calculator 5.82 over 1.028, 5.66 will be 5.66 ohms. And for resistivity we have again the same area times 5.66 over the length was 1 point. Oh god, I did a mistake here. I divided with length. This should be 0.414. So 5.82 divided by 0.414, 14.05. I don't like this Outlook, seriously. This OneNote application. 14.05, and this will be ohms. Again, eraser. 14.05, and here the length will come 0.028. This will be 7.3 times 10 power negative 8 divided by 1.028. So this is 9.98 to 10 power minus 7 ohm meter. So I'll again copy the values there. So this is 14.05 and 9.98.